Section 5.4 in Chapter 5 deals with gas stoichiometry, no different than any other stoichiometry that we've done before, just adds one slight new thing that I actually think you guys had last year. So, molar volume of an ideal gas. This is something that is important for you to know. For 1 mole of an ideal gas, which is 0 degrees Celsius and 1 atm, the volume is always going to be 22.42 liters. It's found by using the PV equals nRT, which you can rewrite, solve it for volume. For 1 mole, use the R value, 273 degrees Kelvin, at 1 atm is always going to be 22.42 liters. Okay, we can just cancel out our units to make sure we're left with what we think we should be. STP is another version or another way to say standard temperature and pressure, and that's 0 degrees, 1 atm, 22.4 liters. This will help you a lot. So let's look at a sample problem. A sample of oxygen gas has a volume of 2.5 liters at STP. How many grams of oxygen are present? You can solve this for N using PV equals nRT. So that's 1 atm times 2.5 liters is going to equal N times the R value, 0.08206, times 273. That'll give you 0.112 moles of oxygen, which you can then convert to grams using 32 grams per mole, which will give you 3.57 grams. Another thing that you're going to need to be able to do is determine the molar mass of a gas, and to do that you're going to use this equation. The molar mass is going to equal density times your universal gas constant times the temperature in Kelvin over the pressure. If we were to look at how the units break down for that, you would see that you would be left with the grams per mole, which is molar mass. This equation is important for you guys to remember. Here is an example. What is the density of fluorine at standard temperature and pressure? How would you figure that? Well, density equals molar mass times pressure over R times T. So that's 19 grams per mole times 2 over 1 atm, or multiplied by 1 atm over your R value, 0.08206, times 273, which will give you 1.7 grams per liter. And that is all we have for section 5.4.